Okay, then let's start. So welcome everyone. I'm going to talk about the focal framework today. And we're going to have a lot of things to go through, and my camera is not working. So it's just my voice and the presentation. So we are first going to set some expectations about this presentation. I'm going to talk about the background on the focal framework very quickly. I'm going to sort of put focal modeling as a part of the ensemble modeling technique in the family of that. And then we're going to dive into the focal framework, and we're going to touch on 3 areas. It's going to be the focal modeling idea or theory, and then we're going to talk a little bit about, we're going to talk about the method data model that is part of the architecture, but one part of it, not the whole method data model. It's too big for that. And then we're going to touch on the physical implementation pattern. And then we're going to do a wrap up on about this. So let's just start. Just to set the expectation, you go on a data vault modeling course with Hans Hultgren. You have 40 hours of video sessions, 3 days of course of modeling. And then you know data vault modeling, but you still doesn't really have a clue on how to do a good implementation of a data vault. We have 1 hour to touch on architecture, modeling, design, and implementation. So things might feel a bit fuzzy and hard to understand. But I hope that you will get a high-level understanding of the focal framework and maybe even get a hint of the possibilities. Some background. This has been around since 1998. It was created by Per-Olof Eriksson, POE, called PO. He's here today, so you can check him out and bug him with questions if you want to. It has been implemented on certain industries like bank, insurance, telecom, and manufacturing. There is a company called Top of Mind's Focal, which is responsible for the standard of a focal framework. It's not just Top of Mind that is part of this company. It's 4 different companies owning it 20% each. We are sort of collaborating around this. So let's jump into ensemble modeling techniques. This is my take on it. So not everyone might agree. But what makes an ensemble modeling technique? Well, for me, it's that they all break up into different constructs to support certain kinds of functionality. So there is always a core business concept or an ensemble that represents and holds the unique identity of an instance of that concept. And it's only sort of the only thing it has to do is to keep track of the identity. That's what it's supposed to do. There's no history and so on. And then we have associative constructs. There is always an associative constructs between 2 different core business concepts. There are never any inheritance between them when you have a relationship between them. Even if it's a one-to-one, you still have this associative construct in between them with the ability to hold relationships both from one-to-one up to many-to-many. And then we have descriptive information is broken out into its own constructs as well, directly related to the core business concept. But that's where we hold history about the core business concept instances and how we describe them. And this is the ongoing theme within the ensemble modeling techniques today. So you have data vault, you have the hub that represents the core business concept, you have the link that holds associations, and you have the satellite that holds descriptions. And in the anchor, we have an anchor for the core business concept, we have knots for the association, and we have attribute constructs to hold descriptions about the core business concept. And in focal then, we have what we call a focal, of course, as a core business concept, relation to hold the associations, and descriptors to hold descriptions. And when you look at these three from a high level like this, you can't tell them apart really, because they are looking and behaving the same way. Of course, if you go into detail and zoom into them, they have their own quirks and functionality and how they handle data. But on a high level and the main functionality for agility and flexibility, they all have look and feel the same, so to speak. So that's why focal is part of this area. Now let's talk about focal modeling. The whole focal idea sort of centers around what we call the focal conceptual model. And this is a representation on a high level of data. So the focal represents an entity or core business concept. And then the descriptive information is split out into different areas, what we call descriptor concepts. And then we have relationships. Why we are doing this is because we want this to help you to understand your data models better, to dig into the data or the attributes as such and understand them. Because think about it, if you're gonna put an attribute into one of these areas, you need to know in what area it belongs. So each of these descriptor concepts has a definition, what kind of attributes that belongs in these areas. So be able to put an attribute there, you need to understand the attribute to have the ability to match it against the descriptor concept. And that sort of helps you, or as some people say, force you to understand the data model or the business on an attribute level as well, and not only on a core business concept level. There also one thing it does is that it sort of, since this model is always the goal for every focal you build, it doesn't ever sort of have any table that says this is source system 1 table, this is source system 2 table, or anything like that. The data is always split out into these generic concepts. So there will never be a source system specific table. The whole model you implement will always be subject oriented, even on attribute level, so to speak. So it helps you not to end up with source system specific tables and stuff like that. And since these definitions of these descriptor concepts are generic, they are also industry agnostic. So you can use this on any industry and still help you to understand their business. When doing a focal model, we are using what we call the focal forms from 1 to 5. And this is nothing new. It's just how a lot of people work. And this is, I mean, for the first 3 steps is more or less is like doing Elm model more or less, or a data vault model on a logical level. So first we find the core business concepts. With step 2 or the form 2 is to find the relationships between them. And the third step is to find the attribute that describes the core business concepts and or the relationships. And this far, we have the same look and feel like a data vault, more or less. But then Focal has these 2 unique steps. First is that grouping the attributes into descriptor concepts. And then we have the 5th level, which is called the atomic context among the attributes. And I will talk more about the atomic context when we go further into the presentation. But first, let's do a quick, very small logical model and go through the step of the focal forms and see what happens in the model. So focal form 1 then, we're going to find the core business concept. And in this case, we find that this business is working with loans and they have customers. And they can have a relationship between these, that a loan can be owned by a customer. And then we talk a little bit more with the business and they come up with certain attributes that they think is important. They have a loan amount, start date, end date, length, risk category, customer name, loyalty level, and we put them onto each sort of focal. At this point, we are more or less looking like a data vault model on a logical level. Now we move into the focal, more specific area. So the focal form 4 then. Group the attributes into descriptor concepts. Well, so how do we do that? Well, it's by talking to the business, of course. So they have come up with this loan amount. So we talk to them about what does this loan amount mean? And they might answer it, well, it's the amount, the original amount we signed together with the customer, the money that we're going to lend them. So it's the one that they sign and that we agree upon. And from our perspective, as soon as something is that we sign or agree about the thing between two counterparts, it becomes a condition. And condition is one of our descriptive concepts. So then we say, okay, loan amount. Okay, then that's probably a condition then. And the business probably looks at you a little bit funny and says, yeah, whatever. And then we go on and we ask them what loan start date is. And they explain that this date represents the date when the customer can use the money we're going to lend them. And before that, they can't reach the money, even if they have signed the contract. And that seems to be something we agree upon also, and that it steers the way we work against our counterpart. It becomes also a condition. And then the loan end date and the loan length is all because they are describing the period of the loan, and they normally have very short loans, these credit facilitators. And then they have risk category. And when we ask them about what risk category is, then they might explain that, well, it's the way to set the risk on the different loans that we have. And then we have that so we can look at our loan portfolio and understand how much we have in each risk category, and we can group and segment the data accordingly. And when they start talking about grouping and segmentating the data accordingly to understand their own business, we end up in the classification area, that you classify data. So by talking to them, we come to the conclusion that we have 4 conditions and we have 1 classification. And then we talk about the customer, and they have customer name. Well, name, we have a name concept, so that would be pretty easy. And then we talk about loyalty level, and loyalty level, it seems that that's depending on how many of their services they're using their product portfolio, they can rise in level from bronze, silver to gold and get certain benefits. And that way they can understand their customer and segmentate their customer groups and do certain kinds of campaigns on them and stuff like that. And then we end up with a classification. So we split them up. But to do this, we need to talk about them. We need to talk about the attribute. We need to learn what they stand for and what they're used for and how they work in the business process. And once we do that, it's not that hard to put them in the right bucket, so to speak, in the right descriptive concept. Once that is done, we move in to find the atomic context among attributes. The atomic context, as a definition, is one to many attributes that can answer an atomic query. And that sounds a little bit funny maybe, but let me give you an example. If someone asks me what my first name is, I would say it's Patrik. So that question can be answered with that single word, my first name. What's your first name? It's Patrik. As you notice, I didn't answer at the same time what my shoe size was, how much I earn, and what car I drive, because it's atomic. And this is the idea around atomic context. But we have 2 different kinds of atomic context, and we talk about simple atomic context. Those are the one that has sort of one attribute needed to answer your question. What's the customer name? It's Patrik Lager. Okay, answer. What is loyalty level? Well, it's A or gold or silver or whatever. And so those are the simple. But when you come to more complex, is that you need more than one attribute to answer it. As an example, I usually take a balance. So if someone asks me, what was your balance, your end of day balance yesterday? I first, of course, need to check out what was yesterday, what date it is. So I need a balance date. I need the date of the balance when it was active. And I need to know which of the balances we're talking about. We're talking about the end of day balance. So I could answer, yeah, yesterday my end of day balance was 1,000. And 1,000 what? So something is missing here, right? Because I didn't answer the question really. So when you think about it, I need the currency. Otherwise, that value 1,000 doesn't make any sense. So currency is needed also. But if I have the date, the balance, and the currency, I can answer the atomic question. What was your end of day balance yesterday? It was 1,000 euro or SEK if I didn't have that much money. So that's the idea around atomic context. Of course, people might start thinking, oh, that sounds very strange. But it's just a way of working we do in the Focal. And we will look into how that yaks into the physical implementation later on. But as an example here also, one of the things we sometimes do when we go down to Focal Form 5 is that we find out other attributes that are missing. So we start looking here, we have something that calls loan amount. And when we start talking about loan amount, something pops up exactly as we discussed about the balance. It's a monetary amount, but there is no currency. And if you ask the business, they would probably say, of course, there's a currency. Everyone knows there's a currency. Yeah, but what is the currency? Well, it's the loan amount currency. It's the loan currency of the loan, of course. So maybe loan currency. So then you sort of find new attributes as well that were missing because people take things for granted, so to speak. That, well, this is an amount. Who cares? Currency always exists, or does it? So then you break it out. Here in this case, we added loan currency as well because the amount need a currency for us to be able to understand. And then we have the period of time. We have the start date, end date, and the loan length. We usually group periods when you describe periods into this kind of cluster of attributes. And then in all of these, as you can see, these yellow boxes now, they got names on them. They're loan amount, loan period, risk category. That's the definition. That's the name or the definition, the name or identity of the atomic context that keeps these attributes together, that represents this. At this point, we have reached Focal Form 5. So this is, in the end, the logical model for a focal modeling session. This is what you end up with. So now after we're done, so this has been sort of a quick walkthrough about how to do models in or logical models in Focal. Now we're going to move into the metadata model and talk a little bit about that as part of the architecture. The metadata model is a predefined, you could say. All the focals and their tables already exist as part of the focal frameworks. And if you do an implementation of focal, you just run the DDLs and then you have the metadata set up, so to speak. And it contains 3 areas. It's a technical area, a functional area, and a semantic area. The technical area is more or less about keeping control of what data that enters your system or what data you send out or whatever. So it's like a batch solution, how to handle batches or streaming data or micro batches and so on and so forth, but to keep track on what kind of data is moving through the system and where it came from. A functional area is also about a lot about sort of traceability and support when doing certain kinds of code solutions and stuff like that. It's more depending on your technical solution, your technical implementation of Focal that you chooses can use the functional area or not. And then we have the semantic area. The semantic area is the representation of models. That might sound strange, but the semantic area is the heart and soul of the whole Focal solution. This is where everything starts, really. And we are going to look a little bit closer into the semantic area. In the semantic model in this area, we have what we call the model for models. It's a representation, it's an ability to represent data models as rows of data. So each of these blue ones is a focal. It's a core business concept when describing a data model. So you do create, if you implement a model into this area, the model itself will get a key, and then what different entities it has. So let's say we would implement our business model that we used before that had, so we call it business model. That would be one instance in the model focal. And then we would have the entities. We had loan and we had a relationship and we had customer, right? And then we would describe what attributes did they carry and what domains do they use and what domain values could these domains give you. So this is a way that you can implement data models in a physical structure to be used further on in your use or in your implementation of the focal framework or the focal warehouse. So this part is that you keep models separated from each other. Each model has its own rows and they are not related to each other in any way. What we do then is that we use this part that we call the integration area, that we shows how do they relate to each other. How can these different models relate to each other? And this is very much used in the focal, if you use it for a focal data warehouse, to do semantic integration. And what does that mean? Well, it's to take one attribute from a source and say that this attribute is really another attribute in our business model. So it changes, so it translates their attribute or their vocabulary in their source system to our vocabulary in our data model that we has implements in our focal warehouse, our integration model, you can call it, the model, the target model for the data. And we also have the ability to translate values. So if one source system might have their own currency codes, not using ISO currency, but we want to use ISO currency, we need to translate that their currency code means something in the ISO currency code area. So this is implemented. These are also implemented as rows into these areas, these sort of integration instructions that we have. And then we have some more parts over here, and then we also relate. Everything here relates within this metadata model. You can travel between the different areas. So you can go from, let's say, an integration point and say this to this attribute from that, this moves into this central, and you can move from the functional model into the technical model and see what kind of file was sending it and what source system is it, and so on and so forth. So everything is related within the whole metadata model. So you have a very good way of to have auditability on things in it. So that's the semantic model. Now if we would if we would take this one, I will now take this one, this area, and show you how it can look like if we would collapse these, denormalize all of these focals into a view, which we normally do for ease of reading it. So here's an example. So if you remember our model that we used before, that we did before in our little exercise. So here we have a business information model, and we say, so this model key represents. So this model key, am I still online? Do you hear me?
Yeah, we can hear you, but you should stop sharing the screen.
Okay, okay, something. Let's see. There we are. Can you see it now?
See it again. Yeah.
So, okay. So here's an example. If we would denormalize that, all of those focals into a view, you could see that here, if we want, it's all dependent on what you want to show, but this is just an example. So here you have a model key then. That would be the focal key, right, for one model. And then we have the name of that, which is a description of that key. This would be in a descriptor table. And so that would be part of the model focal. And then we have the entity, and we have a key for an entity and an entity name. And then we have an attribute key, because even the attributes becomes their own sort of instances of data that we want to describe. And here we only give them the name. And then we can have a domain, and then the domain name. And if we move down here to a currency, you could see then that we say that loan currency attribute uses the ISO currency code domain. And here we could say that with the domain value code is euro, and that would be European Union currency. Another would be SEK, the Swedish krona. And you could see all of these things because we sort of implement the models as rows in the database. And further down here, we could see that, let's say we implemented a source systems data model, and we could call it ABA here. And they have an ABA loan, and they have something they call AirCat as an attribute, and that's used in an R category, and it has some kind of numeration here, and then there's a name of those numerations are. So different models can lie within this area, separated from each other. It's just different instances of data related to them, related within each model, so to speak. So the BIM model has the relationship to all its entities and attributes, but the EBA model has only to its own attributes and stuff like that. But then we use that to represent if we want to, let's say, read or implement or ingest data from the EBA system and their EBA loan area, then we would create an integration, a semantic integration. If we remember, this part, this area here is one part of it, is a semantic integration, which gives us the instruction on how to integrate the data. So this is an example denormalization of that area. And you could say that we call as the EBA would be the source model. The EBA loan could be the source table where we get the data from. They have a source system that's called AirCat, or a column in their table. And there we have to translate that one is really A for the risk category attribute that we want to put this in. So this is a mapping. This is what you normally do when you try to integrate data from a source to a target model. So this is just a way for us to capture that data into our metadata and use that when we ingest data. So we don't end up with source specific data in our business warehouse, but semantically translated data that we can store independent of source system. Because as I said before, we are not really aiming at building source system specific warehouse. We are aiming at building subject-oriented integrated data warehouses. That's what the focal architecture is all about, more or less. So that is a little bit how we use the metadata model, which might sound a little bit strange, but it's really, really efficient. Now, let's talk a little bit about the implementation pattern. As you can see, we have 3 different components that we working with all the time, and that's the focal conceptual model, right? The one that's the target, that's what we want to be able to implement. And then we have physical table patterns, as we call them, and then we have table pattern code. And these components in architecture is that the physical table patterns is related to 8 unique SQLs. Now, I say SQLs because we don't decide upon which technology you're going to use when you're going to implement a focal warehouse. It's just generic SQLs that holds the logic for ingesting data and integrating the data into these table patterns. And each of these table patterns are connected to one or more of these conceptual or these descriptor concept. So one of these table pattern can support more than one of these descriptor concepts, but that is already sort of designed and decided in the architecture which descriptor concept are using which of the table patterns. And then we know which table pattern uses what code. So it's already sort of decided. And we call them table patterns because they are not designated to a specific focal or entity. They are always implemented according to the pattern, and they never change. Even if you add new attributes, they never change. And we're going to look into that. How can I say that? Here's an example of a DDL. So if you would implement a classification for a certain focal, all you have to do is to find replace of this focal tag here, and then you can run it, and then it's implemented. But if you want to do a loan CL, then you call the focal loan. If you want to do a customer, you change just to customer. The table looks the same, independently of focal. And the reason for that is that we're using typed tables instead of flat tables. So if you look here, we have a flat table which is having the attributes that we were discussing before, right? We have a loan amount, we have a loan currency, we have a risk category, we have loan start date, loan end date, and period length. And this is the normal way to do things, right? This is everyone feels at home and everything is as normal. But we are sort of not doing that. As we said before, we want to store our data accordingly to the atomic context we have come up with. So here's one of the atomic contexts we came up with. It was a loan amount is the atomic context name, and it contained loan amount and loan currency. And you can see loan amount and loan currency here in the flat table. When we implement that, it becomes that. So you have loan amount is a representation of our atomic context. And then here you have the value of it. And here is the currency. If we then go to risk category, it was just one attribute. We have the risk category up here. And the loan key 1, 2, 3, 4 has the value A. So it becomes its own row. And then we had the loan period. But that contained a start date, an end date, and a length of that period. And that gets implemented on one row because, as I said, it's an atomic context. We keep the data of an atomic context on one row. So people sometimes react, oh, that's name value pair, but it's not, because we are keeping more than one attribute for each and every type, because we are working at the atomic context level and not by single attribute all the time. The only reason why we end up with it is because sometimes the atomic context is one attribute. So the one row here became 3 rows here. But as you can see, the whole modeling part in the logical model also drives down into the physical implementation then. But what does this really mean if you think about it? Well, it means that if you do a flat table, you need to know, what am I supposed to load into this table? And you can't design it before you have it. In the focal solution, you can design your data warehouse or your solution before you know anything. Yes, I know a lot of people now sitting here and saying, well, I can generate my tables. I don't do tables normally. I generate them. Yes, you generate them. We don't need to generate tables. We have a construct that is already ready to absorb data, as long as you model it accordingly to the focal pattern into the atomic context that they have. So in that case, since the physical patterns then, as they are looking like this, never changes, and therefore the code never changes, you can build the solution without even knowing what data warehouse you're going to build. Because as I said before, the focal conceptual model is industry agnostic. It just groups attributes into different generic concepts, and we break them down into atomic contexts, and then we can apply them to any of these physical patterns. And the code for loading those physical patterns are always the same. So the implementation of a focal is technologically agnostic, because you choose your ETL, ELT solution technology that you want to use. You choose your storage platform, and then you translate these 8 SQLs into your ETL, ELT technology. And they are not hard. They are not big. They are not very complex. It's just that they integrate the uses the metadata model to execute themselves. And you create the DDLs also, of course, according to your storage platform, because they differ sometimes between Oracle and Microsoft and so on and so forth. And then you run the DDL scripts, and then there exists a basic setup of the metadata model to have certain kinds of attributes to use to describe other models. But that's what you can do. So if you think about it, you could, in other words, choose a technology and a storage if you were a consultant company, and you can build it. And then you can implement it at any customer. And you don't need, it's not that you come there with an advanced generation tool or something that you're going to sell them. You are just saying, no, you're using that ETL tool and this storage technology, and we have the code to implement your data warehouse there. And then you own the code. You don't have to wait for us to do any update or a generator or whatever. If you want some new functionality, you own it. You can develop it, keep developing it, make it more advanced if you want to. As long as you keep within the focal pattern, you can add any kind of functionality you want really to your code. But it's your code. Okay, so let's go back a little bit just from the architectural point of view and point this out again. So we are keeping data and metadata apart in the architecture. We have a data model, and then we have the semantic model. The data model, the physical data model without the semantic model is impossible to understand, more or less. Because let's look at it. So here we have a normal flat table, And you can see loan amount, loan currency, risk category, loan start date, loan. And it's sort of, you can understand more or less what this is. In this place, we have a type key. It says 1, and there is a value, and type key 2, and that says 1,000 in euro. There is no possibility for you to understand what is the data here. But at the same time, is that this might be easier to understand. But if you want to know what risk category means from a business perspective, you will probably not find it in your data warehouse. You probably need to go to some kind of vocabulary somewhere, sort of find out, search for it, read about the risk category, and maybe also what does A stand for? What is risk category A? I have no clue. But in the focal implementation, we have always an full access to the metadata layer. So you can read all you want, depending on how well you have defined and described your attributes and your and your atomic context. You can get all this information with a simple join, because there's always the join through the type key up to the atomic context key. And it's the same independently of table. It's the same join every time. So it's repeatable. So it's not that you, depending on this table, I have to do this join, or depending on this attribute, I have to do a lookup against that table or whatever. It's always the same join. It's always repeating. So it's very easy to build views where you get the translation. So you should always read the data, the physical data, with the help of the metadata. And you can decide how much information you want. This is very much information of it, but you could also just take certain parts of it and say build a view where you have just the name or as one of the definitions and so on and so forth. You can decide yourself, but you always have it at your fingertips. It's a simple join. You're sitting at the computer at your database. You just do the join, and you can pick up any kind of definition or name or anything about it. Okay. It seems I've gone a bit faster, but that's good, I suppose. There's something I will take that you could take with you as a wrap up here, is that the focal framework then uses an ensemble modeling technique, the focal modeling, of course. And the focal framework has a very strong metadata model that is sort of the heart of the solution. It works around the focal conceptual model, which is industry agnostic and can be used to help you understand different companies and how they work. And the physical implementation is also industry agnostic, because you haven't no of the tables are predefined to hold a specific amount of attributes. It's ready to absorb any attribute that you want to store in your data warehouse. It's technologically agnostic. You can choose whatever ETL, ELT technology you want to use. You can choose your storage platform, and then you just translate these predefined SQLs to your technology, and then you're good to go. There is also that when we add data, there is a non-destructive change into our model. So we could maybe go back and look at that. So if we look at here, right? So if we would like to add another attribute here, we would have to add a new column into this table then. And that would mean a destructive change, because we need to drop the table, and we need to create a new table or add a column. We could just add a column if it's in the end. And we need to change the code to be able to load that. And we know we have built a sort of advanced generators that can generate this for you. But in the focal area, you don't need a generator, because it just absorbs the data that you want to store. And if you think it from so we have a non-destructive change to an attribute level, and if you think about Anchor way of doing this is that they add a new table. So here's a new attribute. That's a new table. They never touch any of they never touch an attribute table if a new attribute comes along. It's just a new attribute table, and so they never have any destructive change. But in the other hand, they have structural change, right? So they have to add new tables every time a new attribute comes in. We don't need to do that either, because as long as it is data that belongs to a descriptor concept that we have employed, and normally we deploy all the descriptor concept for each focal, and then we use those that have being used. And so they just absorb the data that you want to pull in. There's no change in code. There's no new code. There's no change in code. And there is no new tables. So it's just very, very stable. And that means that we don't need a code generator when we are building a focal solution. So just as a end thing here, I have created a script, or there is a few scripts. So for anyone that is a little bit more curious, how does this work? He talks a lot, but I don't understand really what he's saying, and want to try it out. I have done a script, and we're gonna upload that together with this presentation, and then you can, if you have an MS SQL, you need to Microsoft SQL because it's built. The script was built. Well, that was the thing I had on my computer. So it's Microsoft SQL, but that's, you could download an Express version if you want to. Just and then, so it's a very limited implementation of a focal warehouse like thing, and it's just one of the 8 SQLs, and there are 3 of the table patterns, and then there is a small part of the metadata model, really small, and then there is a step-by-step description of what you do. So you don't have to code yourself. You just do the steps, looks at the data, see what happened. Okay, now I did this, now that happened. And you might get the feeling of the possibilities you can have within the focal framework. So that will exist for those that are interested to be a little bit more on the technology side, so to speak, and try it out. And the end. So I just want to thank everyone that took their evening off here to listen to me talking about focal. Thank you.